The question is, an athlete completes one round of a circular track of radius r in 40 seconds. What will be his displacement at the end of 2 minutes 20 seconds? Athlete completes one round of circular track of radius r in 40 seconds. Complete one circle, the time takes to 40 seconds. What will be the displacement at the end of the 2 minutes 20 seconds? So 2 minutes means 2 into 60, 120 seconds. For completion of one completion, the time taken is 40 seconds. Therefore 2 minutes means 40. So we get 3 complete rotations. For 2 minutes 3 complete rotations, and the extra is remaining 20 seconds. So starting from here, he completes 1, 2, 3 complete rotations, remaining 20 seconds. For completion of one circle is 40 seconds, so half of the 20 seconds from here to here. This is the starting point, this is the initial point, this is the final point. This is 20 seconds and remaining 20 seconds. For 20 seconds means this is a half circle. So circle radius, we know this is r, is the center of the circle, and this is also r. What is asking? What will be his displacement at the end of the 2 minutes 20 seconds? He is asking displacement. Displacement means the shortest distance between initial and final point. So therefore the displacement is equal to, this is r plus and remaining distance r, initial final. It need not depend on the path, it is independent of the path. So you select the initial and final point, therefore the answer is r plus r 2r. Second option is the correct answer. The question, a ball is dropped into a well. The water level in the well is at a depth h below the top. If the speed of sound is v, then after what time the splash of sound is heard? A ball is dropped in the well. Suppose this is a well. Water level in the well is a depth of h. Suppose these are the water and depth is h. The ball was dropped. The time taken to reach the water surface is t1, and then the sound is returned. The splash of sound is heard. Here the time taken to heard the sound, that is in t2. The total time is t is equal to t1 plus t2. t1 is just like a freely falling body. Here the initial velocity is 0. From the equation of motion or time of descent, that is t1 is equal to under root of 2h by g, and remaining second t2, the sound is heard is, the velocity is nothing but distance by time, in which a time t is equal to, distance means h, v is the velocity of the sound. So that is t2 is equal to h by V. The total time T is equal to under root of 2h by G plus h by V. In this equation, so h is takes common, that is equal to h of under root 2 by hg plus 1 by V. This is the final answer. The question is, a ball is thrown vertically upward from the top of a tower. Velocity at a point h meter vertically below the point of projection is twice the downward velocity at a point h meter vertically above the point of projection. The maximum height reached by the ball above the top of the tower is. So this is the top of the tower. A ball is thrown vertically upward from the top of the tower. Thrown upward from the top of the tower. Velocity at a point h meter. So suppose you select this is the maximum height h from here to here. This is the maximum height. But at a height h, you select the point. This one is h. H vertically below the point of projection is twice the downward velocity at a point h meter. Same height from the downward of the top of the tower. This is also h. So assume with the velocity at on top is v2 and bottom is suppose v1, but the condition is given the vertical above the point of projection, the maximum height reached by the ball. So vertically above the point of projection, the maximum height reached by twice the downward velocity at a point. So v1 is equal to twice means 2 v2. So you calculate the maximum height. The maximum height is equal to how much? So thrown upward with initial velocity u. Here two cases. So reach the maximum height. This is the first case, and reach at the height above the top. This is a second case, and below is third case. So first case 1 for maximum height. So v square from equation of motion, v square minus u square is equal to 2as. So at maximum height, velocity is 0 square minus u square is equal to a is the minus g, moves upward, s is the maximum height is h. Therefore u square is equal to minus minus gets cancelled, u square is equal to 2gh. This is equation number 1. And in case 2, again you take v square minus u square is equal to 2as. V square is equal to u square plus 2a. Yes. In the second case, the v is v2 square, u is same, u square. So moves upward, we get minus of 2a is the g minus g, 2g, s is the h. This is equation number 2. In case 3, in the similar way, this is a downward. From equation of motion v square minus u square is equal to 2as, in which v is the v1, but v1 square is equal to u square plus here at this point the initial velocity is also u square plus height is h, 2gh. In the v1, but v1 is equal to 2v2, substitute here. v1 is the 2v2 whole square is equal to u square plus 2gh. So 4v2 square is equal to u square plus 2gh. This is equation number 3. So equation 2 sub in equation 3. Therefore 4 v2 square means u square minus 2gh is equal to u square plus 2gh. Here the 4 is multiplied. 4 u square minus 8gh is equal to u square plus 2gh. 4u square u square. Therefore we get 3 u square is equal to 8 plus 2 10 gh. Then equation 1 is substitute here. The equation 1 is substitute here u square. So we get 3, what is u square? 2gh, capital H maximum height is equal to 10 gh. 2 1 ja 2 5 ja. So we want maximum height, and gg gets cancelled. Therefore maximum height h is equal to 5h by 3. This is the answer. Second option is correct.